this subnetting stuff can get overwhelming to some people. And the most common thing that I run into on a day-to-day basis is people not being able to understand the concept of being able to block your ranges. And that's basically what this. It's basically all subnetting is finding your blocks and applying them. So basically, what I've done is I'm grabbing. Ooh, we have options. We're gonna grab two subnets, 10 network and the 172 network. Nothing complicated, nothing drastic. Simply, how do you break it down? Let's assume the telco gave you this is your subnet range and this is your subnet range. Telco wouldn't actually give you these ranges because they're the private addresses, but for the sake of argument, we're just going to go with that. So, what I've done here is I've laid out. Oh, that's a horrible arrow. Whoop! I can't believe I just did that. So we're just going to retype that in there. We're going to type in 172.17.0/17. So basically, telco gave you this range right here. Or, I'm sorry. That is a horrible arrow. Better. You're going to want to reference this when you go into the exam. This is the bit placement in the class C. Well, actually, this is, draw a line right here. This is C. This is B. Okay, and basically this is what you want to reference when you go into the exam. Notice how I have my addresses right here, and basically all I did was, as you can see, as I took the bit placement, the 18 or 128, 64, 32, 16, 8421, and what the subnet mask range would be. Well, 128 obviously would be the first bit, so it would be the 128. 192, 224, 240, 248, 252, 254, 255, and then /25, 26, 27, 28, 29, 30, 31. It's supposed to be a 31. But who's counting? So you take this into consideration when you're going to the exam. Now, nice thing about this, when it comes to subnetting, it carries from C to B to A all the way down the line until, well, it really does, because all you're doing is you're adding up the bits. So for every bit you add, it's another slash notation, and slash notation is how you're going to reference things in the routing table, so you know how many ranges. The easiest way I can explain this to you is this. I won't even need that. Is this class C? Okay, I know I've got class C. It's broken down to where, but it's you got 1, 2, 3, 4, 5, 6, 7, 8 bits. You need 8 bits per octet in order for it to work. So what you do is when you have one range, you know you have 254 users. Okay, so if it's easier for you, just go by 250. It'll still add up, well, for the most part. So basically what you want to do is for every bit placement going this direction to the left, okay, you want to add 254. Just add 254. So that'll give you how many subnets you had to work with in that range, and that'll make it easier, because a lot of people have it. It's easier for them to subnet a class C range and then break it down from there than it is to break down some like major supernet of /20, which has got what is that? 1, 2, 3, 4, 5 class C addresses. Because basically what you're doing is you're adding up how many hosts you have per network and dividing it. So that's basically all you're going to want to do. So once you find out how many users are going to be at a building, so let's say for instance you get 400 users. Okay, so you know that /24 is 254, the /23 is 510 because it's 512. Then you know that /22 is going to be 1022. How do you know that? 1024. This guy is going to be 2048 or 2046. It's 1022 or 1024 times 2, which is 2048. So you take 2046. This guy right here is 4094. And you go on down the line. That's all you're doing, is you're doubling the total package. And then all you do is you take this and you go, okay, well if I've got it's going to take 2 of these ranges equals /23 is going to be 2 class C's, and all you're going to do is you're going to add this number to it. So if you've got a /22, you've got 4 class C addresses. You get /21, you've got 8 class C addresses. 16, you've got 16 Class C addresses. That's all you're doing is you're breaking it down. Just multiplying it. That's the easiest way I can make a reference to it. People can subnet Class C addresses all day long, because then what all you're doing is you're just splitting it in half at this point. So this gives you 126 users per subnet. This guy gives you 62. This guy gives you 30. This guy gives you 14. This guy gives you 6. This guy gives you 2. This guy, well, /32 is usually host routes. So that's the easiest way to make the reference. I don't even have to subnet this, really. All you have to do is go based on that. That's the easiest way I can reference it to you. Now, there are a bunch of other ways. There are more ways under the sun to subnet than there are ways to make chocolate chip cookies, I guess. I really don't even know a good analogy for that. But what I can tell you is this. When you've got a solid understanding of how bits work and where they fall, this stuff right here just comes naturally. There's nothing complicated about subnetting. People make it sound bad because they don't get binary math. If you can understand the concept of you've got zeros. I know you guys are hearing clicking, so I'm gonna try not to do that too much. Zeros and ones. Okay. You got 8 zeros, 8 ones. So if you've got a 1 turned on, that means there's a bit turned on there. Okay. There's a 0 means this bit is not used. Actually, that looks more like a 6. If the bit isn't turned on, this is added. If the bit is 0, this is not added. So at this point right here, it's 128. If we add a bit here, it means it's adding 32 to that. Okay, and then if this bit is not turned on, it's a 0, and this bit is turned on, we have an 8. Okay, it's a horrible 8. That's a little better. And then we have this bit turned on as well, so we take that 4. And then we turn, this bit is turned off, this bit is turned on. So we have a 1. So we need to take 128 and 32 is 160, right? Yeah, 160. And then we have 8 is 168. And then 4 is 172. And 1 is 173. That's how you do it. That's all you're doing, is you find out what bits are turned on by reverse engineering it. So you figure, so we would take this 175 right here, let's say that was the IP address, and we want to find out what the binary equivalent to that would be. Well, how many times does 175 go into 128? Well, it goes into more than once. We have leftovers. So we know it's going to be 128. I'll put it down here below. Okay, so 64 would make it too much. 32, 1 fits inside of there. So it's not going to be a 0 or a 64 in there because I make it a 192. So you take that 1 and you go, you come down here to the 32. Does that fit inside? Is there leftovers? Well, yes, there is. So we're going to do that. We're going to say, okay, we're going to drop that down to 32. 16 would make it too big because the fact that it would bring us to, it would be a 176. It'd be 1 too many. So what we end up doing is we take this and we go 0. No, that does not equal, it would be too many. Well, does 8 sit inside? Well, yes, it does. So we put a bit there. Does 4 sit inside? Yes, it does. What about 2? Well, 2's too many. So we'll click in, don't turn that bit on, and then the 1, turn that bit on. So we have a 128, a 32, an 8, 4, 2, or an 8, a 4, and a 1. So 128, 32, 8, 4, and 1 equals 175. That's how you are able to determine what your bit, what you're turning on and turning off. It's also known as Boolean ANDing. So you take whatever bits are turned on. So you take a, let's see here. You take, let's say 224. 220. Well, actually, let's make this interesting. A 227. No. We'll make that a 228. Okay. We'll make that a 228. Well, how do you figure out what a 228 is? I've only got 128 through 64. No, you don't. You got 0 through 255. That's what you have. So you take the 228, and you say, okay, well, I've got, I'll go down here at the bottom. 128 goes into 228 quite a few times, with 100 left over. Well, what about 64? Does that equal up to it? Yes, it does. So you go 64 and 128 is 192. So you have that. What about 32? Does that come close? Yeah, actually it comes real close. You put a 1 there. That's actually 227. Or I'm sorry, 224. Is a 224. So that's a slash 27, as you can see right there. So you have, actually I'll recant that statement. So you have that. So how do you get to the rest? You got 224. Well, you go 0, 0, because 16 would be too many. 8 would be too many. 4 fits the bill. What about 2 and 1? Well, that would put us over. So 0, 0. You just keep going down the line until you fill in all the spaces, not to exceed 255 per octet. If you do exceed 255 per octet, you need to drop that down to where, what's the best way to put this? That's a range, and then you need to leave. That's 8 bits. If you have all the bits are turned on, that's 1 octet. So then, if you have more than 255, you need to go to the next octet and keep adding. So then you know that if this guy right here is another is 512 because 256 is 256 and 256 is 512, right? So you have 512, and then you add 2 to that. So 512 times 2 is 1024, right? And then 1024 times 2, or 512 times 4. Same difference. That's all you're doing, is you're taking the bits that are left over and you're moving them into this range, and then into this range, and into this range, and going on down the line until you've figured out how many ranges you need. Same thing with the slash 17. This is encompassing the entire Class B and Class C addresses. You can't. The only one bigger than this would be a slash 16, which would be the entire range. So what I would do is, if a network administrator gave me this range to apply to my building, I'd be like, you do know that that's 65,000 addresses, right? Because this guy is, this is 512, this is 1024, this is 2048, 4096, this is 8192, this is 16384, I believe. This is 32768, and this is 65535. So you know, if you've got a 7/17, you're going to have 65,535 hosts that you can do for one subnet. You break that in half, you got 32,768. Break that into quarters, you have 16,000. You break that into you break that again, you're going to have 8192 per subnet. Break that down again, it's 4096. You break that down again, it's 2040 or 2048. Break that, keep going down the line until you have, let's say you got slash 28 as your mask, and you've got 16 hosts per subnet, and times however many subnets. So in this case, it would be probably a few hundred at this point. So you just take, how many times is 16 going to 32 or 65,000? That's basically what you're finding out. So subnetting is no more difficult than multiplying. If you can multiply by 2, you can figure subnetting out, because it uses the power of 2. So it's, where'd my thing go? Okay, there it is. That's all you're doing, is you're taking and adding the power of 2. I don't even have to subnet this. You can. It's really simple. It's not hard at all. But you need to find out what range you're going to be working with. So with the slash 27, I know that's going to be it. I know that's going to be my range, is 32. So my first range is going to be 172.17.0. Yes, .0 32, and then it'll be .0.64 because I'm in this range. Slash 27 is in the class C octet, and then that falls inside of this guy. So this guy sits there and keeps going to 96, 128, I believe it is, and keeps right on going down the line. And then when he gets done with that, then he increments to the 1, okay, and then keeps going down the line. So 32, 128, 160, 192, 224, and then 256, well actually it'd be 255. Technically 256 is turning the going in and adding, going into this range and going up and adding 1. So that's how many you would have. You'd have let's see, 1 to 8 subnets of 32 hosts, and that's how you would keep on going, and just keep right on down the range, keep going right on down the range until you hit what you need to for your host. The whole idea, the most simplest way to look at this, I've just given you a bunch of different ways to look at how to get to a certain number, and that's how you turn your bits on. Bit turned on, bit turned off. If you can't understand that, then you need to take a step back and say, okay, how many hosts do I need? If you're told, well, I don't know, you need to figure that out. Well, then, you know, you may need to go to HR and be like, well, how many people are in the sales department? And they tell you 61. So you go, okay, so you say 61. How many people are in engineering? Well, 29. Well, that's a 9. How many people in IT? And you're like, too many? No, I'm just kidding. They say 35. So, what's the best way to do this? Well, 61 is bigger than 32, so obviously that's going to be /28. Or I'm sorry, /26. This guy is going to be smaller than 32, bigger than 16. So it's going to be a /27. This guy is bigger than 35, but smaller than 64, so it's going to be a /26. So you know you're going to have a slash. You're going to have 0 through 63 will be your first range, and then you're going to have another /26 on top of that. So you're going to have 64 through 128, 127, and then you're going to have a /27 on top of that. So you're going to have a 128 through 160, 159, I should say. These are usable IPs. And then 160 through whatever. That's how you break it down. You start at the largest and smallest. That's variable length subnet masking, or CIDR notation. That's the best, easiest way to look at it. Now, this is more about flyby review, nothing complicated, real simple to configure, real simple to figure out. I don't know exactly how else I could explain it to you. Subnetting is really simple. It took me a while to get it, but once I did, it clicked, and I never forget it. So when I just took and passed the CCNA exam, and there was definitely some subnetting questions on there. I only got hit with one that I had to stop and think about it, but I got all of the addressing questions correct because I know how to subnet. You know, I also know how to summarize, which was the last video I just shot. I'm gonna upload those, and hopefully that'll help you guys out. I hope this has been informative for you, and I'd like to thank you for viewing.